when you take the 10 largest silicon solar module manufacturers, you see they all have a very similar product. Okay, they all have poly, mono modules, they have half cut, they have bifacial. Once you have cracks in your modules, is that they might grow over time. Okay, and the effects may get worse. So this boils down again to the point that if you're buying a grade A product, why would you accept such defects? And of course, in case you decide again to test on site, you may want to have the right to refuse the modules in case of any damage. Hello, everyone. Welcome to this webinar. We're gonna wait another 1 or 2 minutes, so make sure that everybody's on there. If you can leave a short message in the chat that if you can hear us well, that would be great. And we'll start in a minute. All right. All right. Hello, everyone. It seems to be working fine. I get messages here. Thank you, everyone, for joining. It's really wonderful to see people calling in from all over the globe. We have people here from Poland, South Africa, Brazil, even. Wow, it must be very early over there. Welcome. We have people from Spain, India, Thailand, Singapore, Netherlands, Lithuania, Mexico. Mexico, it's another very early bird. France, Italy, UK. There's people from over 25 different countries. Thank you, everyone, for joining. It's a pleasure to have all of you here. My name is Driekus de Roy. I'm the managing director at Sinovoltaics in Hong Kong. With me on the call is my colleague, dear friend Niklas Weimar. He's the CTO here in Hong Kong. Hello. And we also have Benoit van der Maas, who's our business development manager. He calls in from our office in Shanghai. So it's our aim to keep the presentation approximately within an hour. So there's about 40 minutes presentation, and there's time for questions. When you have a question, you can leave it here in the chat, and we'll try to answer as many as we can. The questions, we will answer some during the presentation and some at the end. Okay. So today we're talking about the optimization of purchase agreements, and sometimes we rather call it the purchase disagreement, because the only times you really need a contract is when things go wrong. And often what we see is that a lot of companies, when they're purchasing from the factories in Asia, they use very, very simple purchase agreements. Typically a one-page contract, which more looks like a pro forma invoice. Now, to tell you the truth, this actually very often it works. Very often it goes well. However, at some point you might run into some issues. Maybe you encounter some delays in your shipment. Maybe you receive damaged goods. Maybe you find out there are certain defects, or maybe you even have a warranty claim. And in these cases, we believe you can greatly benefit from a proper contract, or a purchase disagreement, how we call it. And this is what the webinar is about today. Briefly about our company. So our company is specialized in technical de-risking. We've been in the industry since 2009. And basically we perform audits and inspections mostly at the factories in Asia. We're also active at the solar plant level, where we also perform inspections. Our team consists of over 30 quality engineers, and they all have their own specialization. So we have people specialized in solar modules, in inverters, in energy storage components. We have a team specifically for BOS components like cables or isolators. We have people specialized in trackers. So pretty much any component that is used in a PV plant, we're able to inspect. We're mostly active here at the factories in Asia. So we're active in China, Vietnam, Thailand, Taiwan, South Korea. And so most of the work is performed here in Asia. Now here's some recent project references over the past 12 months. Very grateful to have clients in over 35 countries. Here are some client examples. Typically our clients are PV project owners. They're the developers. We work for EPCs. We're hired by financiers. And we also qualify factories and projects for insurance companies. Now here's some examples of factories that we've been active at. As you probably know, we don't buy solar modules. We're specialized in technical de-risking. So, but we oversee a lot of shipments. So the past 10 years, we've seen several gigawatts of solar modules being manufactured in Asia. And we see quite a few things going wrong as well. So we see that a lot of issues can actually be avoided. And the first step to do so is to have a proper purchase contract or agreement in place. So before we look at the different clauses that we recommend to include in a purchase agreement, we'll have a look at the issues that we come across. And Niklas, he will give you some insight on the type of issues we're finding. And this is based on data of our full inspections of 2019. So it's quite recent data. So Niklas, please go ahead and share some information about the things we find at the factory.
All right. Yeah. Thank you, Drickus, and good day to everybody. It's a pleasure to have you all here today. Now, to start with, given the strong nexus between technical issues and the success of a strong purchase agreement on behalf of a buyer, allow me to give you a bit of a background regarding the technical issues that our quality engineers and auditors have witnessed over the past year 2019 on site at various PV module manufacturers, large and small. As you can see on this slide, over 81% of our PV module inspections in 2019 resulted in a pass, while a staggering 18.5% resulted in a fail. That means that at almost 1 out of every 5 inspections, our engineering team found issues with the very modules destined to end up with the unsuspecting clients across the globe, and leaving them and their projects, had these shipments gone ahead, of course, vulnerable to acute and potential failures in the field, and consequently a sometimes likely hefty dent on their ROI. The issues we found at the factories, including big and famous makers actually, as well as small mom and pop makers, are manifold, and I will in the coming few minutes highlight here for you some selected major issues we came across. As you can see here in this table, during 44% of all shipments, major issues concerned cell inherent defects, which are defects invisible to the naked eye and are generally identified via electroluminescence imaging, which is akin to an X-ray of the module. During 31% of the shipments, our team found also modules that suffered from workmanship defects, which includes a variety of defects such as scratches on the glass and backsheet, encapsulant that is not properly cross-linked, chipped cells, laminated debris, and even aesthetic issues such as cell color deviations. Another issue ranking high on our list of technical issues in 2019 involves the manufacturer's usage of uncertified materials, thus effectively rendering the concerned module uncertified and exposing unsuspecting buyers to module assemblies that have never been subjected to stress and safety testing. And last but not least, the proper, or shall I say improper, calibration of the measurement devices by the manufacturers, effectively yielding inaccurate measurement data, was also on top of our issue list in 2019. I will go into more detail now about all these issues. So let's have a look at cell inherent defects. With cell inherent defects, we refer to defects such as different types of microcracks, solder faults, striation rings, and short-circuited cells. As mentioned before, at 44% of the PV module shipments we inspected in 2019, our team identified modules with cell inherent defects, and the largest chunk of those involved modules with microcracks and solder faults. And these microcracks included simple single cracks, cross cracks, dendritic cracks, and cell piercing cracks, so which run from one cell edge to the other and essentially piercing a cell into two pieces.
Nick, if I can interrupt you for a sec. I have somebody on the chat that's not able to hear you. I just want to make sure that that this is just one person and that it's not everybody. Could everyone just leave a quick message that you can hear everything properly? Okay. Okay. Everybody, the others can hear you. So it must have been
maybe the
somebody else's connection. Okay, please continue.
Okay. Okay, then let's go to the next slide. Microcracks, they are a result of mechanical forces or thermal stress on the cells. So in the production process of a PV module, the microcracks, they most frequently occur during lamination of the module, and especially when using encapsulants with a weak moisture impermeability. So if then slight moisture occurs and it cannot easily evaporate, then it may pass through the cracks on the front of the laminate, and which is followed by the oxidization of the contact fingers. And this is one of the many scenarios how a PV module may then degrade over time. Cracks, as you know, they can potentially grow over time, of a longer time in the field, and with the module being exposed to climatic and mechanical forces. So the growing cracks, they lead to electrical resistance in the impact area, and which translates into heat. So we talk about the potential of hotspots. And in extreme cases, those hotspots may turn as bad as fires. So for this very reason, our company's proprietary quality standards take a very uncompromising approach to microcracks, just in order to stamp out their potentially malicious flames early on. Quite frequently during the quality inspections on site at the factories, our team also encounters a colorful variety of workmanship defects, which are either a result of poor primary materials, but often even more resulting from poor handling of those materials during the manufacturing process, poor hygiene, weak standard operating procedures, untrained staff, and incorrectly configured production equipment. So the workmanship defects, they range from scratches on the superstrate or substrate backsheet, chipped cells, laminated debris, cell dislocation and dislocated cell interconnectors, to poor glue sealing, dents and bumps on the backsheet, and even, as you can see in the middle, aesthetical issues such as cell color deviations, which is an issue that particularly buyers in Northern and Central Europe, they pay close attention to. More striking than the workmanship issues at the factories is actually the issue of modules made of uncertified materials or made of non-conforming material combinations. So this is actually one of the, let me call it, big boxes of Pandora. No serious project developer wishes to open, and which is a pretty much rampant issue throughout the manufacturing landscape to a lesser or larger degree. Let me give you a bit of a background. So when a PV module undergoes certification, the manufacturer of the to-be certified module is required to submit a detailed documentation about all the materials used in the production of the to-be certified module. So the module is then subjected to a variety of design qualification and safety tests over a period of often many months. And provided that the module with materials and the combinations thereof also passes these various stress tests, then the module is deemed as qualified and safe and essentially fit for the market. So naturally, of course, nobody would want to employ a non-certified module. The manufacturer is actually required to produce the modules accordingly with the materials and their combinations to meet the certification requirements. And these materials are listed in the so-called constructional data form, or CDF, which is attached to the certification report. So, however, with no institutional oversight in place from the side of the certification bodies, then there's many manufacturers can and often actually also do run afoul of these requirements, and this includes also big makers. You can imagine basically this is like the CDF is like a receipt of a cake where any alteration of the materials or ingredients and their properties and the baking procedure may lead to a notable change of the cake's looks and the flavor and even digestibility. So it is not rare that manufacturers modify primary materials and components and even design details during mass production of solar PV modules. And there's a couple of triggers and reasons for these modifications. So manufacturers, for example, they change primary material suppliers in order to reduce costs. And this is often a major reason to meet either the target price of the buyer or company internal profit margins. Other reasons include that raw materials are modified or even phased out by the supplier, or that a raw material supplier is actually out of business. And this is actually an issue we might probably observe more and more in the coming weeks and months. And there's also, of course, alterations being made because of new technology developments, for example, new solar cell types. And there's also sometimes buyer-side requirements for alterations of materials or for design features. So the only point in time that to take action and avoid a module being made with uncertified materials is actually doing production. So, and once a module is laminated and framed and cured, then not only it is too late, but the conformity or non-conformity and the far-reaching consequences they carry is also not 100% detectable anymore. And even though it should be a given, however, many purchase agreements often lack an explicit requirement that the module is made according to the certificates CDF, including penalty clauses, which would put an additional emphasis on the importance of this issue for the well-versed buyer, as well as a legal backup. And yeah, last but not least, the top issue in 2019 involved the improper calibration of measurement equipment, overwhelmingly the solar simulators, which are used for IV or power measurement. The calibration issues, they range from the improper usage of the measurement equipment itself to the lackluster preconditioning of the module samples. And this is the vast majority of those cases found by our team, is the usage of defective, non-conforming measurement devices, which then had to be replaced. Measurement devices, or also called reference modules, are used to calibrate the solar simulator and need to comply to certain technical criteria as well, which are laid out in applicable standards by the IEC. Being essentially the base module, or those reference modules, for the testing of an order produced on behalf of a buyer. These measurement devices, of course, they need to be of flawless quality. And often though they are not, and you can see in this picture, which is actually an extreme case of a heavily abused reference module. This is an issue that occurs quite often, and in that case, which you can see here, the manufacturer actually back then, breathtakingly planned actually to employ it for solar simulator calibration during a mass production. So, what are the consequences of improper calibration? Well, if an equipment is improperly calibrated, how to say so, when the equipment is not properly calibrated, there can be manifold consequences of those, and they may result in basically measurement data which are not accurate, and depending on the severity of the measurement inaccuracy, they may very well deceive unassuming buyers and make them believe that they receive modules meeting the minimum nominal electrical parameters as described in the data sheets of the modules. Moreover, our team, they also witnessed cases of intentional manipulation and tweaking of both calibration parameters as well as the measurement data, which is subject almost worthy for a standalone webinar. Thus, as you can see, there are many potential and real technical pitfalls which should be pointed out and countered by a proper contract optimization and also technical due diligence. Jukes, he will walk you now through the key points of how to optimize a purchase contract to counter those issues and others.
Klaas, by the way, if anybody has any questions at this point. Okay, I see one question that we can answer now. A moment, let me just pull it up. Niklas, maybe you can answer these questions.
Okay, let me click here. Oops, 1 second.
The question is, how does EL image resolution affect results?
Yes, so of course, when you have the low resolution you have of an EL image, the less, either manually, less you can see with the eye. So if you have a very low resolution, you might not be able to detect cracks, shunts, finger breaks. So all kinds of defects which may be minimal, but they may, come in large quantity on the cell level. And it is there are requirements, or there should, well, at least in good standards, there should be requirements to define those minimum resolutions or image slices. So to make it short, yes, the image resolution has quite an effect on the results, and this also applies for both the manual usage, so looking at the images with your naked eye, or by software. So for our company software as well. So you need we need high resolution images to get to proper findings. So it's in the interest, of course, of analysts to see to have high resolution EL images.
Yeah, and if I may add to this is also a requirement that can be included in a purchase contract.
Yes, there is actually exactly image sizes and image resolution that should be clearly defined. Yeah.
Okay, thanks for this question. Then let's start with looking at contract optimization. Our basic principle here is that when you're paying for, what we believe is that when you're paying for a grade A solar module, that you should accept nothing less than a flawless, high quality product. Okay, you're paying for a grade A product. This is what you want to receive. So in terms of the objective of having a purchase contract in place, the way we see it is you have this contract because you're aiming for the highest quality product. And aside from that, because you want to have timely delivery, okay, you want to avoid any delays, and you want to be protected in case anything goes wrong. Okay, so this is why we want to optimize a purchase contract. It offers clarity. So we'll have a look at 10 clauses that we believe should be included in any contract. Of course, there are several more, but these are just 10 key clauses to highlight. The first one is to implement your own quality standards and avoid the factory standards. Now, when you take the 10 largest silicon solar module manufacturers, you see they all have a very similar product. Okay, they all have poly, mono modules, they have half cut, they have bifacial. So their product line is very similar. The thing is, when you study their quality standards, you realize that they're completely different from one factory to the other. Okay, and when you sign a procurement contract, you automatically agree to use the factory standard. And what we see is that the majority of the factory standards are quite weak. They're not strict. And of course, there's always a few factories that have very strict standards, but they also may not always follow them. With other words, you may buy solar modules with defects, for instance, micro cracks, but you would still meet the factory standard. Okay, and don't take my word for it. It's just to illustrate this. Let me show you a couple screenshots from factory standards. Okay, just to give you some examples. Okay, these are all screenshots from top 5 factories. So these are the major players. On the image on the top, it says this module is okay. You see an inactive cell part. Okay, this is the kind of things that are unacceptable when you start inspecting. You don't want any such defect in your shipment. Okay. Another example. This is another screenshot. These are bubbles in a module, bubbles under the glass. This standard allows up to 3 of such bubbles underneath per cell, which is of course a lot. It has to do with the wrong cross-linking of the EVA, or it may have to do with improper configuration of the vacuuming during lamination. So again, this is unacceptable. Another example, This is about, again, this is electroluminescence image. These are chipped cells, and this factory, they allow 3 chipped cells per module. And if you read the description, the area needs to be smaller or equal to 10% of a whole cell, which is actually a very big part of the cell. It's 10% of the cell, which would really degrade the performance. So you can see factory standards are typically very loose. Okay. So our first recommendation is you implement your own quality standards. And if you don't do that, the least you should do is ask which factory standard you're actually buying your modules. You know, but what is the standard we're agreeing on, and very carefully review it. We have quality standards for any type of module, including half-cut cells, bifacial modules. So we're able to assist in providing you the quality standards to add to your purchase contract. Okay, so that's the first clause. If you have any questions about this, feel free to ask, and we will answer them. Okay, well, there's one question. That's an interesting question. Let me pull that up. One moment. Question is this 10% not already included in the power measurement or in the flash test? Now this is it's hard to answer as a yes or no question. It's possible that such defects at the moment that you test those modules in the factory, it's possible that these modules are perfectly producing the power that you're buying. Okay, so it may not affect the performance at this point. Is that correct, Niklas?
Yeah.
But then there's also a different story about micro cracks, that once you have cracks in your modules, is that they might grow over time. Okay, and the effects may get worse. So this boils down again to the point that if you're buying a grade A product, why would you accept such defects, right? Why would you from the start already know, okay, the power right now is okay, and we know there's cracks, but you know, let's just accept them. This is not how we see it. We believe that product needs to be flawless from the start. Okay, so that's our take on that. Yeah. Okay, the second clause is to avoid the usage of uncertified material combinations. Okay, and Niklas already spoke about this, how important it is that you just stick to a certified material combination. Now, when you read about cases in the field where you hear about a failure in the field, for instance, I know about a project in Spain. It was approximately 30 megawatt, and modules, they were delaminating. And the first thing that you might ask is which brand was used, or who made the back sheet, you know. But it's typically it's not really linked to a brand, that the brand is bad or this brand does a good job. It's typically the cause that has a different cause, and typically when we see such failures, it has to do with the usage of wrong material combinations. Okay, and again, like Nicholas explained, it goes back to the certification of the modules. So a factory has a module, they certify it, they very carefully pick the materials, and this material combination passes all the tests at the certification body, which is, you know, certification bodies that are TÜV Rheinland, for instance, Kiwa, TÜV Süd. So once they pass all these tests, the factory, they can now sell this certified module. Okay. However, they need to stick to the exact material combination that they use during certification testing. Now, it boils down to basic chemistry. Not every material adheres the same way. You know, you cannot switch a backsheet and think, okay, the adhesion is going to be exactly the same. The risk is that if you change change the material, you're basically using an untested material combination. So you have an untested product. And this is where massive failures can come from in the field. The materials may be very high quality, but the material combination has not been tested. And one point that is important to know is once a solar module has been made, typically it's impossible to know which materials have been used. Okay, of course you can see the brand of the junction box, but it's very hard or close to impossible to know which type of EVA or backsheet or glass was used. And therefore, the verification of the materials that have been used can only be verified at the factory. Okay, so and preferably before the production starts. So this is what we help a lot of customers with, and this should definitely be a clause where you emphasize that the factory needs to stick to the certified material combinations. And like Niklas explained, those have been those are embedded in the CDF, construction data. Okay.
Just the question.
This is maybe this is Niklas. This question is it's a good question. In your experience, what is the degree of acceptation of the PV module manufacturer for changing the factory quality standard? Yeah, this is of course something a lot of
So to start with, of course, this. So as Rick has mentioned, every maker, they have of course their own criteria, and but of course, in their interest, they try of course to minimize their own costs, and anything that is gets rejected that increases the burden or capital burden basically on the factory. So of course the standards are geared towards their capability of making a good module or not, or is according to their setup. Now, when you are a buyer and you basically you want to implement your own quality standard, it is very important to do this early on in the commercial discussions. So because they gear the quality standard to the value or to the price basically that the buyer pays, and of course also it depends on the size of the order and basically your relationship with the manufacturer. So these are the reasons that are behind this, and manufacturers they may basically negotiate on this, and they may try also to raise prices. Anytime we actually succeed in this in having the clients, or if the client wishes so, our standards basically being applied for an order, and many times actually without actually additional capital burdens on or basically increasing prices. But it has to happen actually early on. So if you already are through with most of the terms of the agreement and then start very late on to discuss on this, that may actually greatly reduce your potential and chances to get this right. So this is one of the points to do early on. And and naturally, as said, if you have really big projects, of course, the bigger that is, the more and more accepting a manufacturer is on this. On top of that, plus of course your relationship.
Yeah. And maybe good to mention is that that our standards have been accepted by all the major factories, and it's not so much about pushing it to the impossible. There always needs to be a balance between what is a reasonable request, and it's not about making it so strict that there's only one factory in the world that can make it. It's about having a standard that is complete, so it covers all potential problems. So once a problem comes up and it's not included in the standard, then it's automatically a pass. So it's also about how to make sure that everything is covered. And there's one more question which I'll just pull up about the to prohibit the usage of uncertified material combinations. The question is, isn't it best to include the module bill of material in the contract and verify it in the CDF before signing? Now, yes, you can actually include specific materials that are going to be used in the contract, but this is also to keep in mind. A factory has various material combinations certified, okay, and that's because if one supplier suddenly cannot supply a backsheet, then the factory needs to be able to order it from another factory, okay, from another supplier. So there is not one fixed recipe, there is several material combinations possible. And if you limit yourself to one module BOM in the contract, then the factory can only buy those materials, okay? There cannot be any deviation. That also means that if suddenly one material cannot be supplied, then you have a problem with your order. At the other hand, there are some of our clients that actually very specifically test one BOM, one bill of material upfront with accelerated aging tests to make sure that this is the very much most durable material combination they can possibly use. In that case, yes, why not? Why not include your BOM in the contract?
Yes, you could even actually, if usually you should, of course, or it's advisable to have, to basically to get the CDF also early on, and then make a very clear reference to the CDF version and date, because they also of course they undergo updates, and and if you specify this very clearly, then of course you can handle that issue basically with having your own BOM cross-check with a very specific CDF that applies to the point of time when you intend to buy or when you buy. Yeah, so specific naming.
Okay, let me see. Was there anything else about this topic? Okay, let me move on to the next clause. Okay, next clause is about implementing the actual inspection procedure and accepting criteria. Now, this boils down to having the control to find out what exactly are you buying and setting the terms on when are you satisfied to accept the modules. Okay, simple as that. And we see two moments in the supply chain that we recommend to verify what you're buying. It's at the factory before your modules are shipped, and perhaps upon arrival at the PV plant construction site. When you're receiving modules that are not meeting the highest standard, you really want to have a clause in place that says, okay, we want to have it replaced. So, so this clause, what it would specify is inspection procedures, it specifies sampling levels, it specifies that you have access to the actual quality data, the measurement data from the factory, and this specifies that you have the right to actually replace the modules when they don't meet the right standard. Okay, so that's the clause that we recommend here. Then the fourth clause is to have acceptance criteria after delivery on site. Okay, now you want to build in a possibility to file a claim in case there's visible or invisible damage to your modules once they're delivered on site. And for the majority of our clients, we see that it's actually the factories that are they're handling the logistics. Okay, and in that case, you want to build in a clause where you say that you want to have the possibility to test the modules they come in. And on site, we really mean on the project side. So after all the logistics have been done. And it may be important to have this clause in case there's any suspicion of any damage during shipping. And of course, in case you decide again to test on site, you may want to have the right to refuse the modules in case of any damages. So this is what we recommend. And I see a question coming in. Okay, DDP, DAP terms, they're becoming more rare. Yes, it's true. When you have a FOB contract, in that case, we highly recommend inspect everything at the factory level. Okay, so the moment the goods are picked up at the factory, you're 100% confident about the quality. Okay, let me see if there are any other questions that. Okay, maybe there are somebody I think is still typing. We can answer that later. Okay, fifth clause. Fifth clause is to store the quality data. Okay, there's a lot of data about the quality of your modules produced at the factory level, we see the data about your PV plant. It's like the maintenance record of a car, right? You want to be able to prove that all the checks have been done. Your plant is in the best shape possible. Therefore, you need to make sure that the factory saves all the data that has been produced at the factory. This includes IV measurement data. This includes electroluminescence data. And then later on, when you have any issue ever in the field, you have this whole data set, and you can check back to see, okay, were those issues present at the factory or not? So you can see in the entire supply chain, you have records of, can we track this? Now, often we see that factory, they don't save any of the testing data. Okay, this may be by mistake. It's hard to tell, but of course data leaves traces. And in our opinion, all the data needs to be saved for the entire lifetime of the plant. Okay, and like we discussed earlier, there's also certain requirements to this data, how it's recorded. So there's certain resolution of images. There's certain criteria and certain calibration criteria for the IV measurements. Actually, many of our clients, they ask us to save their testing data. And another aspect of it is if you want to be 100% sure that all the testing data collected at the factory is correct, we recommend to have inspectors actually calibrate the machinery, calibrate the IV equipment, and this is something we can assist with. Okay, I'm just going through the questions. Yeah, this is a good question, but maybe something for later because it's not related to the clauses. Okay, let me move on to clause number 6. This is a penalty clause in case of delays. Now, we all know that delays are pretty common in the industry. Now, the current situation in China with the coronavirus outbreak is of course causing massive delays for everybody. This could be a topic by itself. But if you look at delays, the delays are very common in the supply of modules, and it has to do with very often with the imbalance between supply and demand. It's almost like a cycle that we see occurring in the industry. There's time of shortages, there's times of oversupply, and this makes delays an issue that comes back all the time. And what we see is during those periods of shortages, it's actually very often it's the clients that that pay more, that pay a premium, that receive their product. It's not always on a first come, first served basis. And there's ways to protect yourself from this contractually. So you can protect yourself from delays, protect yourself from price hikes, and we highly recommend to include a penalty clause. Okay, and in case of a shortage in the market, when you have such clause in place, it's very likely that your shipment get prioritized. Okay, there's never a guarantee, of course, but this is contractually, this is as much as you can do. Yeah. Okay. Some other questions coming in about sampling. Maybe we can answer that later on. Termination clause. Okay. Now we see that sometimes factories are not able to supply, but it's not only the factories that sometimes cannot fulfill their contractual obligations. Sometimes it's the buyers. Okay, and it happens that a buyer is not able to proceed with a purchase. There can be various reasons. Maybe a PPA is cancelled, tariffs can change. There can be all kinds of valid reasons to walk away from a contract. And as long as you have a contract in place, of course, that allows this flexibility. So this is to have a proper termination clause in place is valuable. And there's even the possibility to build in a clause to be able to cancel a contract without any reason given. Okay, this is called the termination for convenience clause. So that's a clause we recommend to include. Okay, let me move on to the next clause, number 8. We see some of our clients having to deal with the lack of verified PAN files when they're buying modules. So we suggest to have a clause in place that the seller provides a third-party validated PAN file. Now these files, they're used for PV systems, of course a PV system design software. And you want to make sure that you're using a validated PAN file. And when some of our clients, they purchase new, so a PAN file, there's a question now, what is a PAN file? A file, this has all the specifications, it includes all the specifications of the solar module. So all the electrical specs, basically. And it's used when you're using a PV system, when you're making a design of your PV plant, you pull up the different components, and you rely on that these PAN file, that it has the exact electrical specs of the modules for the actual design of the system. When it deviates, then your design is incorrect. Now, sometimes we see that clients, they're buying a brand new module, something that is just on the market, and then there's no PAN file yet, and then the factory just shares something that's almost similar, this cannot be relied on. So what we recommend is that you have a clause that you're always sure that the seller is responsible for providing you with the latest updated PAN file, which is a third-party validated PAN file, not just something put together, but something really this module has been tested and electrical specs have been included. There's another question if the PAN file includes more information than the usual data sheet. It includes a lot of information, temperature coefficients, electrical specs, anything needed to, let me see, I'm just pulling up some notes. Yeah, so it includes all the electrical specifications at STC, but on top of that, it has a lot of other things, such as the shunt resistance, Yeah, if you're interested in that, drop me a line later, and I will send you the full list of what a pond file includes.
Yeah.
Yeah. Okay. Pond files, by the way, they've been around since 1992. PVSys has been. These guys have been around for 28 years, and one stands for Panneau Photovoltaic because the software was initially coded, was initially in the French language. So it's been around for a long time. Okay, clause number 9 is to specify the sorting and packing details of solar modules. Now, there's different ways to install solar modules, and one of the ways we see a lot is that for utility scale projects, modules are installed. The modules that are used they need to be very close in terms of their IMP, their current at maximum power, and this will actually maximize the yield per string. Now, in order to actually manage this, your solar modules, they need to be sorted according to IMP and packed accordingly at the factory. Okay, and some factories are doing this properly. They're used to it, and we also see that a lot of factories, they just do whatever they want to do, whatever suits them. So the way to properly sort modules needs to be specified in your contract. And this is a clause about how the modules are sorted and packed, so that when you install them, then it's designed to produce the maximum yield. Additionally, there are standards and best practices for proper packing. These can also be contractually agreed. Okay, then the final clause. This is about payments. It's actually just a small part of the clause about payments, but this is just a general thing that we recommend, is to pay a balance payment upon inspection approval. And yeah, this allows you to be in full control of your shipment. We typically recommend our clients to make a small down payment and pay the balance when all quality requirements have been met. So a down payment can, for instance, be as low as 10%. 90% balance would be paid once the inspection company gives the green light. Now, this way, you as a buyer will always keep the leverage to make corrections, as of course the factory likes to get paid. So this way, you keep the leverage in case there's any defects. You have the leverage to say, okay, this has been agreed in the contract. Any defects that we found, they need to be replaced. So this final clause ensures that only when you're 100% confident about what you're buying, this is when you pay your balance payment. Okay, that was the final clause already. Let's see, we had a few questions that came up. I think we organized them, Niklas.
Yeah, so let's maybe start. Okay, maybe start with, I just see here this one. So that question came, what you recommend between pre-shipment inspection versus control during production? Yeah, I mentioned before that when the topic came up regarding the the verification of of the proper usage of certified materials, yeah, the only point of time you see this is actually during production. So whatever happens afterwards, it's very hard to track. I mean, you can, of course, you can take documents and cross-check them, but this is a second best solution. And documents can also be, altered. So what you see live, what is used on site is, of course, what is assembled. So the best choice, actually, or the recommendation that we would give when choosing between these options is usually to have, basically a control during production. So We usually call this production monitoring. So that's basically a our case. So there would be our engineers that would be on site and they monitor the production, and then actually a pre-shipment inspection or like a batch inspection on a produced batch is then executed after production of that batch has been completed. So you essentially combine actually this monitoring with an inspection or testing of the respective batch. So yeah, the best choice is always to see what is going on site.
Okay, I saw another question about sampling levels. Let me pull it up.
Yeah.
Can you elaborate on the sample size for pre-shipment inspection? Most of these supplies would propose S2 level. Is general level 1 something that should be requested? Maybe we can highlight the different levels first of sampling. Because S2 is a special sampling level, which is actually very, very low. And general sampling varies between level 1, 2, or 3, right? And level 3 is the strictest. Level 3 would probably apply when maybe you've had huge issues in the past and there's distrust between you and the supplier. And this time you really want to inspect according to a very strict sampling. That's level 3. Level 2 is a very general level.
General, normal default level for many.
And level 1 is already actually a low inspection level.
This is when you have higher trust actually with the supplier, and had a good experience in the past. So some would opt for this general level. Normally, actually, we would recommend at least to go with a default level G2, and if not even better with inspection level 3. It only works in the even statistically it only works in the advantage of the buyer basically to have a higher a more conclusive insight into what is going on with the specific batch. And so in this regard, for the specialized for the S levels, yes, they are of course in the interest of those that do not want to spend much time on that, or any from the manufacturer side, or they basically they maybe are afraid that something could be detected. So of course, if you lower the sample size, then then there's of course a lesser chance from our experience. And it also applies to really mass goods, and we talk about like hundreds of thousands of items where you probably then look at these specialized levels. But in the day-to-day basically operations of a PV module factory and how batches are packed and basically structured, you do not. It's in your interest not to apply these low specialized sampling levels. So you go with the general levels, and as said, minimum 2, if even not better, level 3, G3. Yeah.
Okay, let me see if there were any other questions.
So here we have, I just see this here. So one question was, what EL image resolution do you recommend to put in contract? Well, I mean, if going by our own standards, and it's also applied by some labs, and also some buyers that follow these recommendations. So usually would go with 8.3 megapixels resolution, so that as a standard, as a good basically resolution set up for EL image, and to detect all larger and also tiny cell inherent defects. So 8.3 megapixels.
Okay, let me see what else. else was there? Okay, I believe that's pretty much all the questions. To finish the session, you've seen now the 10 clauses that we believe are useful to include in your purchase contracts. Of course, there's a lot more of content in such an agreement, or call it purchase disagreement. Now, of course, everybody has their own document, so you could instruct your legal department to optimize your own contract, or if you need help, we have a template available. Okay, so we've been advising companies for many years about optimizing their contracts, and we have a template that can be used by every one of you. It's available for free of charge. You can drop my colleague Benoit an email, and he will send you the template. Okay, this is a document that in the past we would never just share for free. It's not available on the website. When you believe it's useful for you, contact Benoit, and we appreciate if you can give some insights about your projects, about what you're working on, and if you see any possibility for us to work together. But in any case, it's free of charge. The second thing we can offer you is a full license. Now, the difference is that it's the same contract, but to make this contract geared towards your specific purchase, we're able to help you at the correct quality standards. So specifically on the type of module, the type of technology you're buying, if it's a bifacial, if it's a half-cup module, it's a mono-PERC, it's a poly module. We have specific quality standards, and also the inspection procedures, they may differ. We have the contract available in both English and Mandarin, so to make sure that the factories are certainly able to read what is agreed on, and this type of full license is available for free for our clients. Okay, so when you hire a company for inspections at the factories or at the PV plant level, we're able to assist you with including all these necessary inspection procedures and quality standards for free. Okay, when you're interested in this, you can also get in touch with my colleague Benoit, and he will help you further, and he can discuss your specific project. Okay. Thank you everyone for attending. Very much a pleasure to see so many people on the webinar today. We're actually going to be hosting many more webinars, and they're going to be regular webinars about various topics. It's always quality related. So expect an invitation for future webinars, and we hope to have you on the next webinar as well. Thank you very much, and
thank you.
Wherever you are, I wish you a good day or a good night. We really appreciate everybody joining.
All right. Have a good day, everybody. Or night.
All right. Bye.
Visit Sinovoltaics.com to learn more.